Okay, we are going over lesson 75, how to write the equation of a circle. This is what I want you to look at first of all. The equation of a circle is given by the following formula, so this right here, where HK is the center of the circle and R is the radius of the circle. This will make sense here in a minute whenever we go over it together. But just so that you can see, this is the equation of a circle, very similar to how y equals mx plus b is the equation of a line, a straight line. When you see an equation like this, you automatically know that it's the shape of a circle. Okay? HK is the center of the circle, and R is the radius of the circle. All right, let's apply this. It says right here, if A is a point on circle D, see right here, A is a point on circle D, write the equation of circle D. All right, the very first step you want to do is to write the ordered pair of the center of the circle. So, where is point D located?
1, 3.
Very good. So, write this down, center, H comma K, and write down what y'all just told me. 1, 3. Then, I want you to look right here and tell me how many units it is from the center of the circle to the outside of the circle so we can find our radius.
3.
Very good. So this is 3 units. 3 units, which is where we got R equals 3. Once you have this information, the center of the circle and the radius, then it's time to write the equation. So, look back up here. We're going to write down x minus 1, because 1 was our x coordinate, squared, plus y minus 3, because 3 was our y coordinate, equals 3 squared, because 3 was our radius. Did I lose you anywhere in that? Okay, stop me if you have questions. The second part says circle E is concentric. Remember, concentric means that they share a point. So it could look something like this. And they're both at point A, just to review what concentric means. Circle E is concentric with circle D and has a radius of 5. Write the equation of circle E. So, it's going to have the same exact center, but a different radius. So we're going to rewrite x minus 1 squared plus y minus 3 squared equals 5 squared, because that is our new radius. Okay, moving down to this next part. It says the equation of circle P is x squared plus y squared equals 25. Graph circle P. All right, the reason why this looks different than this is because it's at the origin. The center is at the origin, which is 0, 0. So technically it's something like this. X minus 0 squared plus y minus 0 squared equals 5 squared. So if you're confused and wondering why it's condensed like this and it doesn't quite look like the equation of a circle, it's because the center is at 0, 0. And so there's no need to write x minus 0 squared, right? Because once you simplify that, it's just x squared. But now we know that 0, 0 is our HK, meaning our center, and the radius is 5 units. Right? Because we took the square root. Right here, let me highlight it in case y'all missed it. I took the square root of 25 to get 5. Okay, I have everything I need now to graph circle P, which I was instructed to do. So, I'm going to put a point at my center, and I'm going to label that P, because you name a circle by its center. 0, 0, the origin is where the center is. And then we're going to go out 5 units to the right, put a dot, 5 units to the left, put a dot, 5 units up, put a dot, 5 units down, put a dot. So 5, 5, 5, 5, and in the best of our ability, we're going to try to draw a circle. And there we have it. We graphed circle P. All right, last one. It says the equation of circle Q is right here. X minus 2 squared plus y plus 1 squared equals 16. They want us to graph circle Q. Now, I want you to pay close attention. We know the x coordinate is going to be 2. But watch this. The y-coordinate is going to be a negative 1. Because this is what's happening here. Let me expand it out before it was simplified to show you what happened. It actually looked like this. This is what it looked like before they simplified. Do you see this double negative right here? That's where they got the plus. So my center is actually located at, let me write this down, HK is 2, negative 1. That's a very common mistake that students overlook. So I'm drawing your attention to it so you don't overlook it. And then my radius is 4 units because you square the 16 to get the 4. All right, time to graph. Start with our center at 2, negative 1. So that's right here. We label that Q because they called it circle Q. We're going to go up 4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. To the right 4. 1, 2, 3, 4. To the left 4. 1, 2, 3, 4. And then we're going to, as best we can, connect those dots to make a circle. And that's lesson 75. Questions before we move on? Lesson 76 is something you've been studying since first grade. Symmetry. We're going to expand on it just a little, but not much. Symmetry. So first, let's start off with some definitions. Symmetry is a property illustrated when the image of a transformation of a figure coincides with the pre-image. So that first blank is coincides. The line of symmetry. It's the line that divides a figure into 2 congruent reflected halves. And then rotational symmetry, a type of symmetry that describes a figure that can be rotated by a point less than 360 degrees. So it's got to look the same before it takes a full turn. Because all figures look the same once it's made a full turn. So it doesn't count as rotational symmetry if it has to go all the way around. But I'll explain that more here in a minute. Okay, super simple. Identify whether each figure has a line of symmetry. If it does, draw the line of symmetry. So take a couple seconds to do that for me using these 4 shapes. Draw a line of symmetry if possible.
So just write like yes or no, or we actually have to draw?
If it's yes, just draw the line for me. Like cut the shape in half.
Okay.
2 reflected halves. Okay, the heart, we can draw a line straight down. Can we draw it this way?
No.
No, it has to be 2 reflected halves. This shape, there's no line of symmetry. This one, we can go straight down. That's not the only one, right? We could have gone this way, or this way, or this way. So there's multiple, as long as you had one of those, or even this one. And then for the smiley face, straight down. Does the smiley face have more than one?
No.
No. Okay, so that's just a review of the line of symmetry. Now for rotational symmetry. These 3, there's nothing really to write. I'm just going to go over them with you real quick. So do you see how this is a 180-degree turn? Meaning if I flipped it upside down, it would look exactly alike. So we can write down 180-degree rotational symmetry. And this one, let me see. This one actually looks like you could go from here, if you rotate it, to here, to here. See how it has rotational symmetry? And the square, the 90-degree turns, this one also has rotational symmetry. So basically it has to look the same before making a full turn in order to have rotational symmetry. So these down here, I'm going to do these with you since it's not something you do often. So right here with this block letter N, do you think it has rotational symmetry? Would it look the same if I flipped it like a block to its side and then again over upright and then to the side before I turn it 360 degrees all the way around?
No. Yes.
Yes, no,
I was
maybe.
gonna say yes.
I mean,
You
if you had it on
kind
its
of have
side,
to.
it
Okay,
would be like a Z.
correct. If you flipped it on its side, it would be a Z, something like that, right?
Yeah.
But if I flip it again,
It would be an N.
see how it looks the
So,
same?
Yes.
So the answer is yes. It's a 180-degree turn. And the way they say this, it has an order of 2. So let me read the instructions for you. See, it says, tell whether each figure has rotational symmetry. We said yes. If so, give the angle of rotational symmetry. We said 180 degrees. And the order. Order just means how many times did you have to flip it to get to where it originally was or how it looked. So that's the 3 answers to this one. Yes, it does. 180-degree turn. How many? The order of 2. Now, Let me get my pen back. Let's look at the next one. This one is a lot like this because of the square.
So it would be yes, 90 degrees in one order.
Yes, 90 degrees and order of 1. Okay. And then lastly, this one does not have rotational symmetry. Because if I turned it, it would look something like, oh my goodness. Oh. No. Like this. See, and then if I flipped it back again, it would be under the little groove. I'm not drawing this very well, but you see what I'm saying. This, I'm looking at this groove thing right here. This dip. It moves every time you flip it back. So it doesn't look the same before hitting the full turn. So it doesn't have rotational symmetry. So that's lesson 76. Lastly, lesson 77. We've already been covering a lot of surface area, volume types of questions with specific kinds of figures. This one in particular deals with cones. Y'all know what a cone looks like. We've already practiced using these formulas with pyramids and prisms. Well, today we are applying it using cones. All right, so first, the formulas. This is lateral formula, lateral area. So when you see a question ask you for lateral area, you know to use this one. It's pi times radius. Anyone remember what the cursive L stands for?
Slant?
Very good. Yes, that's our slant height. Slant height. So write that down just in case you have to look back. Then for surface, give me 1 second. Surface area right here, see? For surface area, the formula is the lateral plus, who remembers what big B stands for?
The total lateral area? Don't you have to use the lateral area?
Yeah, that's the L. What is the
Just
big
base.
B?
Your area?
It's area of the base. It doesn't stand for base. It stands for area of the base. So write that down. And then for volume, it's a third of the area of the base, big B, right? Area of the base times the height. So you find the area of the base times the height divided by 3, and that's your volume, labeled in cubic units. Okay, let's practice a few of these so we can get comfortable with them. Calculate the lateral area of the cone to the nearest hundredth of a square inch. Hundredths means 2 decimal places. Okay, so we are going to write our formula for lateral area because that's what they asked for. We need to take pi times radius times slant height. So 3.14. What's the radius in the diagram?
3.
3. And what's the slant height?
7.
Excellent. Punch that in for me and round to 2 decimal places because they said hundredths.
That's 66.
66, yeah.
But it says nearest hundredth. So round to 2 decimal places.
Oh, so 65 point. Just what the calculator gave?
65.94. Is that what y'all got?
Yeah.
Yeah.
Inches squared. If they said round to the nearest square inch, then we could say 66. But they didn't say that. They said hundredth. Okay, why don't you guys try this one on your own? Don't do the next one. I want you to wait for me before you do surface area, but try this one. Calculate the lateral area, once again, same as we did last time, of the cone to the nearest hundredth. So again, round to 2 decimal places. Just make sure you use the correct radius, okay? Okay. Thomas, what's the formula we need to use here?
The lateral area formula.
Which is?
Pi times radius times slant height.
Pi times radius times slant height. Kellen, what did you plug in or substitute?
I did 3.14 times 5 times 10.
Logan, when you punched that in, what did you get in round 2?
157 centimeters squared.
You didn't
was
have
no
2
decimal.
decimals?
No, there was no 2 decimals.
Okay,
There was no
157 centimeters squared. All right, those were lateral area examples. Let's now move on to surface area. It says, calculate the surface area of a cone in terms of pi. Anyone know what that means in terms of pi?
Like leave it with pi?
Yes, leave pi in your answer. So let me write that in there just in case you ever look back at these notes. Leave pi in answer. Okay, good. In terms of pi, with the slant height, see there's going to be our cursive L, our 5 centimeters, and a base radius, there's our R, of 4 centimeters. Okay, we have all the information we need. What's the formula, Gabby, that we need to apply here? S equals L plus B. So, let's start with the L, which we know now is pi r L, slant height, cursive L. And let's plug in what we need. So pi is 3. Oh no, we're going to leave pi in the answer. Haha. So we're going to just leave it as pi because they said in terms of pi. The radius is what?
4.
4. The slant height is 5. So we have a lateral area of 20 pi. We're going to save that. Put it here. Now we need to find our big B. What does big B stand for again?
Area of the base.
Area of the base. So it's a cone, which means our base is a circle. So what's the formula for area of a circle? Area of a circle formula. Anybody?
It's not 2 pi
So
r.
just base times.
It's not 2 pi r, is it?
Nope, that's circumference.
That's hold on. I'm thinking.
Isn't it just radius
Radius
times
squared.
radius?
No, wait. Radius
Y'all are
squared.
getting warmer.
Radius
Times-
times radius.
Pi r squared.
Yeah.
That's what I said.
Pi r squared. So we have pi, what's our radius again for this question?
4.
4 squared, which is 16 pi. So we're going to put that over here because that's our big B. They wanted us to leave pi in the answer. 20 plus 16,
So it's 36 pi.
36 pi. How should we label this?
Centimeters squared.
Centimeters squared because it's area. Excellent. Good job, guys. All right. Now we are solving for volume. It says, what is the volume of a right cone with the radius of 3 and a height of 5? Round your answer to the nearest tenth. That's 1 decimal place. Thomas, what's our formula for volume of a cone?
Pi, base, area of the base times height, 5 by 3.
Yep, area of the base times the height, divide by 3. So, in order to find the area of the base, We use what formula?
Oh, 2
Pi r squared.
pi r squared.
Thank you. Pi r squared. What's our radius for this question?
3.
3. Do they want us to do in terms of pi?
No.
No?
It says round
So we're going to
range.
punch that in. 3.14 times 9, which is
28.26.
and then they gave us the height. Okay, so volume equals 28.26 times the height, which they gave us. They said it's 5, right?
Mm-hmm.
And divide all that by 3. Round to 1 decimal place.
47. Or, yeah, 47.
0.1.
47.1.
One.
And how should we label that?
Cubed.
They didn't give us a unit measurement, did they? I'm just going to say units cubed. It's volume. Remember, volume is measured in cubic units. Not too bad, right? Just follow the formulas carefully. Okay. Try the independent practice and let me see your answers once you're finished, please.
We're only doing it for less